So one of the solution of the big data problem is like, you can go for sharding. What I say sharding is, for example, you have a SQL server, you're having it for the company, and what you can do is you can divide this SQL server into multiple instances, and one instance for one specific department. For example, finance, you can have one specific SQL server instance that takes care of it, and like that you have multiple instances. Or you can do partitioning in a way you can have like by year-wise SQL Server instances, so that you can manage the data growth. But again, if you see, these are all something which you can do when you know what should be the data size after a year, right? You are very clear on what the growth of the data size. And if you're not very clear with the data size, and if you're going with the sharding options, what might happen is, again, you will get into a problem of, the solution is not giving the expected, it's not meeting your expectation. Again, a particular instance can grow beyond the limit, and again you have to find out some other solution. So sharding can be a solution when you know that the data will increase, and it is up to a limit. Up to a limit it can increase if you're very sure about it. But if the data growth is not that predictable, then sharding cannot be a good option. Okay, sharding is like the same as I said, like partitioning data and putting in different instances, or dividing the data in different instances of database. So other solution is NoSQL, right? NoSQL databases are something which are widely used for to store large volume of data, or with the velocity, which is volume and also the velocity, where you get huge data in a day. For example, Facebook messages, if you think of, right, you have to store the Facebook messages kind of events. But what the problem with NoSQL is, NoSQL are solving specific problems. I mean, you want to store the data in a different way, and you want to store the data in it. For example, MongoDB is something, a NoSQL database, which is a document-based NoSQL database, where you want to store the data in a complete structure way. For example, a customer is buying a product. If you see in a traditional database, you would store that information, like customer will be a different table and orders will be a different table, and you will join the table, and then you actually get the information, right, by joining different tables. But when the data volume grows beyond a limit, so one of the thing is, you can store for one customer all the information in one big file. But that option is not there with the traditional system. But MongoDB can help there. It is actually document-based NoSQL database, where you can store a particular customer information about his about his residential address, or his information, or about his transaction that he has done with the company on a different product that is bought over a period of time. All that you can put it in one big document that can be stored as one big document file. So this can solve the problem of storing such information in large volumes by just when the customer size is increasing, you can keep on adding nodes, you can keep on adding multiple machines, so the data gets automatically sharded across multiple nodes, and that way it can solve a specific problem. So NoSQL databases, if you think of DynamoDB, which is key value pair, and if you think of Cassandra or HBase, which is column oriented, or Neo4j, which is graph database, it all solves. There is a specific problem that cannot be addressed by traditional databases, and these NoSQL databases are solving very specific problems. There are specific use cases when you go and use a specific NoSQL database, but it is not more holistic solution for a big data problem. One can solve one different angle, another cannot be used. If NoSQL databases can solve all the problems, then you wouldn't have different types of NoSQL databases, right, in the space, in the market. But if your business case is something which can be solved by NoSQL databases, then you don't have to think of other solutions like Hadoop and all, right? So beyond that, I mean, this is something when you think of Hadoop is something, it can help, it can work along with NoSQL also, but your problem is solved at NoSQL databases. Definitely, it will not be required to go for MPP or Hadoop-based solutions, right? So MPP is called the massively parallel processing. It's again to solve one of the big data problem where you want to store the data and quickly analyze the data. Like you want to scan the entire table. If your table size can be any bigger, you want to store the data and also you want to analyze the data with a pure SQL with all the analytical functions that are there available in SQL, or you want to integrate with any other analytical tool. So all that can be done in MPP. For example, MPP databases are Vertica and Greenplum or the some of the major player in the market, and when customer will go for it. I mean, when they have to, this can be an alternative to a data warehouse environment. I mean, data warehouse environment is something where you move the data from your OLTP, as I said, overnight or specific intervals. And when you move to data warehouse, the objective of the data warehouse to do more analytics. But typically, if you see in any company, when they come up with the business objects or when they come up with something like a layer, business objects kind of layer or components kind of layer, it's mainly used for dashboarding rather than more analytics in there. So you're not able to do analytics with the data warehouse environment. But I mean, when I say analytics, you can do analytics, but it takes time. You will not be able to deal with you will not be able to take the entire data set and then do analysis, and all that is a problem there in the data warehouse. And MPP databases are something. It's alternative to a data warehouse environment where you can push the data into MPP and then MPP databases, and then you can run the queries. MPP databases, they have this columnar-oriented structure, which will fetch the information like in seconds. I mean, like when I say information, huge information, like millions of records, right? So, but the limitation here is it deals with structured data, but doesn't work that well with unstructured data. It doesn't support unstructured data, but to some extent supports semi-structured also. Some JSON format support is also there, but it has specific problem to solve. Again, it's solving a big data problem, but there are specific use cases. Okay, so Hadoop is something more holistic environment. In a way, there is a NoSQL flavor there in Hadoop platform. I mean, I will come to that a little later, but there you have MPP kind of components there in Hadoop framework, and sharding is something which is a default happening in Hadoop. The data is split into blocks and then spread across nodes, and then the processing can be done with MapReduce and all that is there. But the advantage with Hadoop is it's more of a holistic environment where multiple problems can be solved. It's not specific to one. It's not restricted to one specific problem to solve or few specific problem to solve. The way the Hadoop environment is evolving at this point, if you see, it is trying to solve most of the problems with the big data with the different aspects like volume, velocity, and variety. Right, all that can be addressed in Hadoop framework. So let me discuss a little. I mean, the Hadoop project, it is initially started because of the white paper released by Google around the time of 2003 and 2004. Google published a paper for a Google file system and also for MapReduce, and also they published a paper later on Bigtable. So these paper played a critical role for the Hadoop platform that we have now. The duck cutting is the person who was working in Google around the time when the paper was released, and he actually joined Yahoo after that. When he joined Yahoo, there was one very important event happened there. Like Yahoo outsourced. They were trying to come up with the. I mean, in Yahoo with the duck cutting. They were trying to come up with some replica of the Google file system that Google was mentioned in their white paper. So Yahoo and the duck cutting, they were able to come up with something called Hadoop HDFS as a file system, and also Hadoop framework, right? Hadoop framework consists of HDFS and MapReduce. So they were able to come up with some Hadoop framework, and what they did was they just open sourced it.
Mhm.
Then they open sourced it, and that is very important even there, because when they open source to Apache Foundation, it enabled other companies to try it and see the benefit of it, and also contribute back to the open source community. So we have a lot of tools developed on the top of Hadoop platform at this point. It's only because of this particular open source idea. So like Facebook, like if you think of any company which are using Hadoop, they were able to come up with you know they were able to experiment the Hadoop framework, and they were able to come up with the new tools that solve their problem, and they contribute back to the open source, and that way Hadoop framework is evolving. And any tool they contribute back is again open source. Anybody can use it, and anybody can improve it by just taking it from the open source. So it became a top level project at this point. Large active user base, very active deployment, strong development team, all is there. So who are using Hadoop? There are a lot of companies using Hadoop. This is something a little bit old slide, but there are a lot of companies at this point.